This is a Math 3 summary video for the lesson titled Arc Measure Discovery. This lesson is a Solidify Understanding task. The purpose of this task is for students to explore relationships between angles and arc measures in circles. In this lesson, you'll explore relationships between angles and arcs. In this video, we will specifically explore the relationships between inscribed and central angles, exterior angles in the intercepted arcs, and angles created when two chords intersect. Let's look at the relationship between an inscribed angle, angle CDB, and the central angle, angle CAB, that intercepts the same arc, arc CB. First, I'm going to draw angle CAB. Then, I'm going to compare the measure of angle CAB with the measure of angle CDB. I can use translations and rotations to see how many times angle CDB fits inside angle CAB. And I find that it fits twice. This means that the inscribed angle is half the measure of the central angle that intercepts the same arc. You can also say that the inscribed angle is half the measure of the intercepted arc. Remember that the measure of an arc is the same as the measure of its central angle. Next, I'm going to explore the relationship between the two intercepted arcs and the exterior angle. I'm going to refer to the larger intercepted arc as the big arc, and the smaller intercepted arc as the little arc. First, I'm going to translate angle CFB so that the vertex F coincides with point D. Since I'm only translating, parallelism is preserved, so my two orange rays remain parallel. Since these two chords are parallel, they maintain an equal distance between each other. Let's mark these equal arc measures as x degrees on our diagram. Now, since I have an inscribed angle, I can find the measure of the arc that it intercepts. I just need to multiply 20 by 2 to find that this arc that is intercepted by the inscribed angle is 40 degrees. Now that I know the measure of part of the big arc, I can write an expression to represent the entire big arc. I have 2 times 20 for the part that is intercepted by the inscribed angle, plus x, which is the measure of the rest of the big arc, and the same measure as the smaller arc. So my big arc can be represented with the expression 2 times 20 plus x. So remember that I'm looking for the relationship between the big arc, little arc, and exterior angle. I can see that in my example, the exterior angle's measure is 20 degrees, and I use that 20 to find part of my bigger intercepted arc. That 20 came from the inscribed angle, which came from translating the exterior angle. So, since I can see the relationships between my expressions and the exterior angle measure, I can see that if I take the big arc and subtract out the measure of the little arc, I would be left with 2 times the measure of the exterior angle. That means that I can divide by 2, and I would be left with the measure of the exterior angle. Next, we're going to look at the relationship between arc measures and the angle created when two chords intersect. We're going to start by looking at the circle on the left, where we know the measure of the central angle, which means we know the measure of the intercepted arcs. Also notice that we do have vertical angles, so both arc HD and arc FG are 45 degrees. Then, I'm going to translate HG so that I'm creating angles that are not central angles. Now I have points that are approximately in the same location as the circle on the right. Also, remember that parallelism is preserved when we translate a line. So I have corresponding angles, which are congruent. Next, I want to write expressions for arcs CD and FE. I know that the distance between my parallel chords is congruent, so I'm going to represent those arc measures with X. Since the measure of arc HD is 45 degrees and the measure of arc HC is X degrees, I can represent the measure of arc CD as 45 minus X. And then for arc FE, since part of the arc is 45 and the other part is X, I can represent the measure of arc FE as 45 plus X. Now, my diagram has gotten a little crowded, so I'm going to take away the measurements and labels that I no longer need so that I can focus on finding the relationship between the two arcs and the angle measure. The angle measure is 45 degrees, and one arc subtracts some number from 45, and the other one adds the same number to 45. This makes me think about averaging. For example, if X was equal to 5, and I subtract 5 from 45, and I add 5 to 45, I would get 40 and 50. When I average 40 and 50, I get 45. This idea would work regardless of the value of X. So all I need to do is average the two intercepted arc measures, and I will get my angle measure. To summarize, inscribed angles are half the measure of central angles that intercept the same arcs. That means that the measure of the inscribed angle is half the measure of its intercepted arc. Exterior angles, regardless of whether it's created with two secants, two tangents, or a secant and a tangent line, create two intercepted arcs. The measure of the exterior angle is 1/2 the difference of the measures of the two intercepted arcs. The measure of an interior angle, shown here at the intersection of two chords, can be found by averaging the measures of the intercepted arcs. That's it for this video. Thank you for watching.